Okay, let's look at the homework 3.9, number 5. All right, so we're looking at the water trough, which is 90-meter long. All right, so I indicate that 90-meter long here. All right, and the cross section is a shape of isosceles trapezoid. All right, so I drew it here, and it says that the bottom is 20 centimeter wide. So this is same as if you convert it in meters, 0.2 meters. So the bottom is 0.2 meters right here, right? Then also the top is 80 centimeters, right? So 80 centimeters is the same thing as 0.8 meters, right? So I actually, since it's a trapezoid, we know that 0.2 here, and you're going to have 0.3 on both sides. That'll make a 0.8. All right. Then what we need to do is we need to first write down what's given. So let's use V for the volume. So since the water is being poured into the trough at the rate of 0.1 cubic meters per minute, so we know that dV over dt, rate of change of the volume, would be 0.1. So that's a given value. All right, then it says that let's see, how fast is the water level rising when the water is 10 centimeter deep? So I'm going to use y for the depth. So it's going to be 10 centimeter is again converted to meter, so 0.1 meter. So it's actually y 0.1 as well. All right, and then we want to compute. We want to find a volume formula. All right, so let's try to express the volume of the water in terms of y. All right, so first we want to find the cross-sectional area, so which is right here, and which is a trapezoid. So this is the area we want to find first. Then we can just multiply by 9 to get the volume of the water. Right? So let's do that. Right? First we have to find some length. Right? So depth is y. Right? Then look at this triangle. So you can see that there's a right triangle right here. Right? And this is a big one. And look at this smaller right triangle. We notice that those are similar triangle, right? The ratio of the size here, say this right here is 0.6, and this right here is 0.3. So the ratio is 2 to 1. So if you look at the similar triangle here, the ratio of this side to that side is also 2 to 1, right? Since this side is y, this side is 1/2 of that, so it's going to be y over 2, right? Then same thing here, so this is going to be right here is going to be y over 2, right? So this is just a rectangle, so this length in between would be 0.2. Right? So the trapezoid is 1/2 times quantity top base. Top base is going to be y over 2 plus y over 2 is y. Then you have an extra 0.2, so plus 0.2. So that's the top base. Plus the bottom base, so it's another 0.2. Times height. So height in this case is y. Right? So that will give you the cross-sectional area here. Right? Then you just have to multiply by 9 meters to get the volume. Right? So the volume formula is this. right? So let's clean it up. You see that this is going to be, so I have 9 on top, so 9 over, there's 2 on the bottom, so I put 2 here. All right, then we just multiply together, so y times y is y squared. All right, and you have 0.2 plus 0.2, so it's going to be 0.4, then multiply by y. So you have that. All right, if you want that, you can multiply out, but let's see. Why don't we do that? So it's going to be, actually, maybe this is simpler this way. All right, so this is the volume. So let's take the derivative with respect to t so that we can find the dv over dt. So with respect to t, right? So it's going to be dv over dt is equal to, right? So you have a constant 9 over 2. So 9 over 2 here, right? Then the derivative of that would be 2y plus 0.4, right? Then you have to multiply by derivative y with respect to t. All right, so let's plug in everything we know. So you can see that dv over dt is 0.1, so you have 0.1 here, right? So you have 9 over 2, right? Then 2 times 0, y is also 0.1. So 0.2 plus 0.4, so it's going to be 0.6. Then times dy over dt. Right, so cleaning up a little bit, so it's the 2 and 6 cancel out, 0.6 cancel out, so 0.3. Right, so that's so this is going to be, right, 9 times 0.3 is 2.7 dy over dt, right? So we can just divide through by 2.7. We can get the so 0.1 over 2.7 is equal to dy over dt, right? So we can multiply top and bottom by 10 so that it looks a little bit better. So therefore, dy over dt is equal to 1 over 27 meters per minute, right? So that's how fast the water level is rising, right? And we got the right answer right here, right? That's it. I hope that this was clear.